We have seen the different lecture series on the displays up till now. Today you are going to see the practical video of most basic experiment in the measurement laboratory or in the metrology laboratory. The name of the experiment is different angles measurement using sine bar. Let us see what is it is exactly. Angle measurement using sine bar. So, for the experiment to be performed, the necessary equipments that will be required are: first, the different components having different angles. For example, these components are having different angles and we have to measure the angles included in this component. Then we will require a surface plate that will give us a flat surface in order to give a datum to the sine bar as well as slip gauges. Then we will require a sine bar. Now the sine bar is made up of steel and it is lapped up to the surface so that you can see it is having plain surface everywhere. Next we require is a primitive measurement system, that is primary measurement system, called as dial indicator, for accurate measurement of the surfaces such that it can show us when we touch it will show like this for different surfaces, and where the surface is not regular it will go beyond its original dimension. So this is most basic measurement indicator, that is dial indicator. Next we will require a set of slip gauges. Now the slip gauges are made up of material and they are intended to connect each other according to different centimeters they are made. For example, this is 90 that means 9 centimeter, maximum is 100 that is 10 centimeter, and very small is 101 that is 0.1 slip gauge can also be shown over here. So what all over required has been shown in the experiment. So, let us start with what experiment we want to perform. Let us understand the theory behind that. The sine principle uses the ratio of length of two sides of a right triangle in deriving a given angle. It may be noted that devices operating on sine principle are capable of self-generation. The measurement is usually limited to 45 degree from loss of accuracy point of view. The accuracy with which sine principle can be put to use is dependent in practice on some form of linear measurement. The sine bar in itself is not a complete measuring instrument, but another datum such as surface plate is needed as well as other auxiliary equipment. Over here in the diagram, you can see a sine bar is in the angle. The gauge block, that is the slip gauges, are connected to one another, and the sine bar is obviously harder ground bar. Over there, a length, that is distance between center of two rollers, is calculated. Over our experiment it is 20 centimeter standard. Then h, small h, will be made by the number of slip gauges used together, and we will make a calculation using formula. Length is equal to distance between centers of ground cylinders, h is equal to height of the gauge block, and theta is equal to angle that we want to find out. Therefore, sine theta is equal to h by L, that will give us theta is equal to sine inverse of h by L. Hello. So we are going to perform the actual experimentation over here. What we will first do is we will take the angle, or we will going to measure an unknown angle of this right angle component. For that we will require a plane surface. Now with the help of grease, the surface has been cleaned up so that any external dust particles won't affect the system, as well as the surface will be remain smooth. So the grease has been shown over here. Next is that we will take approximately slip gauges, but in order to connect two slip gauges there is a technique, and that technique is called as ringing of slip gauges, where the two slip gauges are taken together. Their flat parallel surfaces are connected in a such a way that the right angle is formed in between that, and it creates a temporary magnetism. So over here we can see that we can make a combination, and while counting we have to see that this is 7 centimeter slip gauge, this is 4 centimeter. So while considering, the height will be taken as 11 centimeter or 110 mm. We are going to perform this experiment. For this we will do one thing. The basic principle that required for use of slip gauges is to use of minimum slip gauges and achieving maximum angle over there. So let us see. This is a sine bar where two different centers are located. The distance between two centers is taken because this is the point which is in connection with the surface plate as well as along with the slip gauge. So distance from point to point is generally recorded. What we will do over here, that we will keep this workpiece like this. Attachment has been done so that the component will not slip over the. Then next is we will add slip gauges one by one, but for adding we will do a specific combination. The ringing of slip gauges is done by doing this technique, and over here we will going to check whether the system is accepting the height or not. Since the dial indicator is having surface, but it will require small slip gauge, again we will take another slip gauge of 0.9 mm and we will connect in the same manner. We will again check this. Then if you can see, the taper angle is now shifted to a parallel angle of the surface plate, but still it requires a smaller. We will take another slip gauge of 0.4 mm. Then to this we will connect in a similar manner. After this you can see the component is properly parallel. We will adjust the dial indicator and we will check on the different surfaces. As you can see, the very first point it is showing deflection. After touching, we will same check at different points. It will show deflection if it is there. Again at different points it shows a deflection. Likewise we will be checking deflection at different points. Therefore the deflection will be counted, and if it is in the permissible region we can say that the component is parallel with the surface plate. So we will sign the dial indicator. Now what we will do for experimentation purpose, since the distance between two rollers is 20 centimeters, either we will take total in centimeter or we will convert it to mm. So 220 centimeter will be considered as 200 mm for mathematical calculation purpose, and the slip gauge total height will be counted. Over here we have taken the first slip gauge that was from 6, that is 6 centimeter or 60 mm. Next we have taken was 30, that is 30 mm. Then next was 9, that is 0.9, and very next was 0.4. So altogether that is 9.4 centimeter, or you can call it as a 94 mm. Therefore for modulation or calculation purpose, now we can say that in order to find the different angles in between these is sine theta is equal to h by l. Therefore sine theta is equal to 60 plus 30 plus 9 plus 4, that is 9.94 divided by L, that is 20, or we can convert 94 divided by 200. Then next step will be theta is equal to sine inverse of 994 divided by 200, and final answer will be related to 44 degree. That is the angle included for this component will be 44 degree. Now, after performing the experiment, we have to take care that the slip gauges are to be engaged with the grease again. They have to be greased up, and after that they will be kept into the box as per the dimensions. The wax paper is generally used in order to protect the slip gauges from any rust, any corrosion, or any foreign particles should not attack onto them. So we will keep all the slip gauges as per their position, and after this, we will take out the sine bar. Again, we will grease the sine bar as per requirement so that dust particles won't affect your calculations. And using this technique of the experiment calculation, we can find unknown angles of any component for sine bar. Only condition is that this is not the correct or accurate method, but this is the precise method or precision method which is used widely in the industry to find angles of different unknown components. If the component is of larger size, then in all that cases, this sine bar is directly kept onto the workpiece or onto the work, and the calculations are made. Only thing is that external plate is not required. The workpiece itself acts as a surface plate, but an external attachment is used, and for that external attachment, this sine bar having different holes into this. These different holes serves two functions. The very first function is for maintaining the weight of the sine bar so that it is easy to use, and second is for any auxiliary attachment. It can serve as a tangible limit over here. So we have performed the sine bar experiment and we have calculated the angle measurement using sine bar satisfactorily. We will see the same series of experiment in the next lecture. Till then, thank you.